Science is inextricable from numbers. So maintaining our comfort and increasing our comfort with numbers and ratios and relationships and just being able to think about them quickly is something that's of value, even though we haven't needed to use it much in this course. So here we have a problem that goes back to the previous semester, the general chemistry portion of the course. And we need to identify which group of objects has a greater mass. I see this symbol Sn. I pull out my periodic table and it tells me it's tin. And I can look at the atomic weight as an atomic weight of 119. Au I find on the periodic table, element 79, it's gold, has an atomic weight of 197. I rounded it off to the nearest one, because we're just wanting to say which has a greater mass. Well, clearly 197 is a greater mass than 119. And all we're doing when we're saying 1 mole, it's like saying, oh, if I had a dozen bowling balls, or a mole of them, would I have a bigger mass than if I have a dozen bocce balls? Still pretty heavy, but nowhere near as big as a bowling ball. So yes, gold's going to be our choice because of the higher atomic weight. Going to this next one, we have 1 mole of bromine, which has an atomic weight of 80, and 6.022 times 10 to the 23rd fluorine atoms. That's a huge number of fluorine atoms, but they have an atomic weight of 19. So we need to compare moles with atoms. And you can do this very easily. I put a number up here on the sheet to remind you that 1 mole is 6.02 times 10 to the 23rd of an object. But we can do the conversion explicitly. So if I start with 6.022 times 10 to the 23rd fluorine atoms, then I know my conversion factor needs to have a particular form. It needs to have atoms on the bottom and moles on the top. And that will help me end with a number in terms of moles. I know that 1 mole equals 6.022, didn't leave enough room, times 10 to the 23rd atoms, and these will cancel, and I have 1 mole of fluorine. So 1 mole fluorine would be 19 grams of fluorine. 1 mole of bromine would be 80 grams of bromine. That one's bigger. All right, for this third one, we have to know something about bromine molecules. And there are a number of things: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen, that like to form diatomic molecules. So a bromine molecule is Br2. That's enough for us to decide that 1 mole of Br2 molecules is going to have a mass twice as big as 1 mole of bromine atoms. That would be our choice there. Let's go to the last one. If you look at, you want to figure out the mass of H2O. So I'm going to take 1 mole of H2O, and I need to know how many grams of H2O there are in 1 mole of H2O. I can get that from the atomic weights. Hydrogen is 1, oxygen is 16, so I've got 2 times 1 plus 16. And that's what I will put here, 18 grams per mole, 18 grams of water. Now I've rounded it off to just the ones place. but that will be good enough for our comparison. Let's look at the ammonium ion right now. Ammonium has a mass, nitrogen is 14 grams per mole, plus 4 times 1, because hydrogen is 1 gram per mole. This is really close to 18 grams per mole, just like the oxygen. So we need to do a conversion. We need to take our 3.011 times 10 to the 23rd NH4 plus ions and convert that to moles. 1 mole is 6.022 times 10 to the 23rd. That's true. 1 mole of anything is that many of the same thing. And we do that and we get 0.5 moles. Okay, let's multiply our 18 grams per mole times 0.5 moles, and we have 9 grams of ammonium ions. So we have twice as much water as ammonium ions, and we would choose the water.